Welcome back. For this session, we're going to go over bond energy. So we're going to talk about the energy involved in ionic bonding. And so, the important thing is we need to form some things first. Before I can have two ions bond, I need to form the ions. And so, in order to form the cation, I'm going to use lithium as an example. So I have my atom first, and I'm going to break the attraction between lithium and its one valence electron, so that what I end up with is the lithium ion plus that electron that I removed from it. That electron didn't just disappear, it's still there. And so because I'm breaking that attraction, think of two magnets. To separate two magnets, do they just separate spontaneously? Do they just separate on their own? No, we need to put energy into the system. So this would be endothermic. We're going to put energy into the system. So my change in energy is going to be positive. So energy going into the system is endothermic. So this would be a positive number. Let's make up some numbers and let's just, actually, you know what, we'll come back. We'll do the numbers later. So this is to form my cation. And if you remember, the energy required to remove an electron to break that attraction is referred to as our ionization energy. Going back to our definition from before about bonding, is that bonding is when we're going to increase our chemical energy. Our potential energy decreases as we form bonds. And so here, I'm going to separate this bond. So I'm going to decrease my potential. So then, we have our anion that needs to form. So let's look at fluorine. So fluorine is going to attract an electron. It has 7 valence electrons, and so it needs to attract an electron to have a complete valence shell, which makes it stable. So when the fluorine attracts this electron, it forms the ion. Since an attraction is forming, our energy is going to be negative. Energy will be released, and so this will be exothermic. This is referred to as electron affinity. But you can also call it electron attraction, since that's essentially what it's doing. It's the element attracting the electron so that it can complete its valence shell. That's all affinity means. So if you want to say attraction, if that's easier for you to remember, I'm perfectly fine with that. So now that I have my two ions, I have my lithium ion, which was formed by breaking the attraction between the electron and the lithium nucleus, and I have my anion, which was formed by the electron being attracted to fluorine's nucleus. When this happens, we have an ionic bond form. My ionic bond, my compound formation, is neutral to make it more stable. Since the bonded together crystal lattice is more stable than the ions individually, my change in energy is going to be negative, exothermic. And if you remember, when I'm forming this fluorine, for example, 1, 2, 3, 4, 5, 6, 7. When I'm forming this fluorine to gain this extra electron, That's just one attraction that's occurring. And so it does release energy because it is attraction. However, it's just one attraction. Well, now that I have these compounds, these unit cells coming together into the crystal lattice, I'm not going to change colors here, I'm just going to do this really quick, but, oops, keep in mind that this is a 3D structure. We're seeing it as 2D, which makes it a little bit harder. So that means here's one layer, but there's also a layer in front and a layer behind. So if I want to talk about this atom right here, this atom has an attraction to this negative anion, to this anion, to this anion, to this anion. The anion in front of it, and the anion behind it. And so there are 6 attractions occurring here. And as we said, when the attraction happens, energy is released, it's more stable. So my crystal lattice is very, very stable. And so it releases a lot of energy. And so now, if we look at this with some numbers, I'm going to make these numbers up. So if you look these numbers up, these are not the correct numbers. Oh, and I didn't tell you what type of energy that was. I apologize. So this energy is called our lattice energy. And that makes sense because it's the energy released when our crystal lattice forms. So my lattice energy is the energy released when crystal lattice forms. And so as we said, that's going to be a very large amount of energy because we have all of those attractions forming. I showed that 6 attractions form, and that was just with one of my ions. So all of my ions are forming those multiple attractions. So a lot of energy is being released. If I were to put some numbers with this, let's just say, for example, that my lithium requires 200 kilojoules per mole. Let's say that my electron affinity, because of that attraction, that I have 100 kilojoules per mole released. Since my lithium fluoride crystal lattice is going to release a lot more energy, I'm going to say that it releases 500 kilojoules per mole. And so now don't forget, this requires energy, so this is a positive energy. This is an attraction, so it releases energy, and this is an attraction, so it releases energy. And so if I want to know the total energy of forming a crystal lattice, it's going to end up being minus 400 kilojoules per mole. Like I said, these numbers are incorrect. It would actually be a lot higher than that. But you can see that when an ionic compound forms, it is a highly exothermic reaction. And because of this, because of the high attraction of that crystal lattice and how close those ions bond together, it's going to form a solid, it's going to decrease the density, and it's going to release heat. So that energy will be released as heat. It will feel warm. Hopefully this helps you understand the energy involved in forming an ionic compound.